Next, configure sensor settings. Select the Modeling tab and select the sensor model. Right-click and select Extract an extract component. And extract a sensor component. To use the sensor, add a frame to specify the detection position, the sensor body, and a Boolean signal to store the sensors on off signals. While the extracted component is selected, select Features and select Frame. Frame is created at the origin of the sensor component. Drag it to the sensor's detection position. Select Behaviors and click Raycast in Sensors. Raycast sensor will be added to component graph. In the same way, select Behaviors and click Boolean in Signal. Boolean signal will be added to component graph. Change name to X100 in the Properties window. Select Raycast sensor in component graph and set max range and detection threshold in the Properties window. Set max range and detection threshold to 100. Set bool signal to X100 and frame to frame added previously. This is the end of the explanation of sensor settings. This section explains how to connect Gemini and GX Simulator 3. First, start GX Simulator 3. Open the GX Works 3 file and select Debug, Simulation, System Simulation, and Start System Simulation. Select Add System, check the project name, and then select OK. Select the checkbox of RD77MS2, Simple Motion Module, and click Start. Write a program to the started GX Simulator 3. On the GX Works 3 screen, select Debug, Simulation, System Simulation, and Connect Simulation. The Specify Simulation Connection Destination window is displayed. Make sure R16 CPU is selected and click Connect. Select the Online tab and write to PLC. An Online Data Operation window is displayed. Click Parameter plus Program, select the checkbox of Simple Motion and click Execute. During the process, a confirmation message is displayed. Click OK. When writing is complete, click OK and close the Online Data Operation window. Return to the System 1 window and click Reset. When Ready turns on, select Run. Next, configure the communication settings with GX Simulator 3 on the Gemini side. Select the Connectivity tab. Select Mitsubishi Electric FA in Connectivity Configuration, then right-click and select Add Server. The Edit Connection window appears. Set PC side interface to GX Simulator 3 and CPU type to R16. Set the type and range of devices communicating with Gemini in Start Device, Points Settings. This time, set 3X devices and 3Y devices that control link_3, 1 coordinate for the current value of link_1, and 1 coordinate for the current value of link_2. First, set the following start device, points combinations, X103, Y103, D1001, and D2001. For D1000 and D2000, set data type to DWORD. After completing the setting, select Test Connection to check whether the connection succeeds. After confirming the connection, select Apply. Click on the icon on the right of Server in Connectivity Configuration. Gemini will start communicating with GX Simulator 3. After the connection to GX Simulator 3 is established, Perform pairing of the variables on Gemini with the devices on GX Simulator 3. First, set signals to be sent from Gemini to GX Simulator 3. Right-click Simulation to Server and select Add Variables. The variables on Gemini will be displayed on the left and the devices on GX Simulator 3 on the right. Select X100 on the Gemini side and X100 on the GX Simulator 3 side, and click Pair Selected. In the same way, perform pairing for X101 and X102. Next, set signals to be sent from GX Simulator 3 to Gemini. Right-click Server to Simulation and select Add Variables. In the same way as explained previously, perform pairing for Y101 and Y102 respectively. Next, pair J1 axis in servo controller in behaviors with D1000 and J2 axis with D2000. This completes the connection settings. Run the simulation. First, start the Gemini simulation. Next, turn on M300 in GX Simulator 3. After M406 turns on, turn off M300. When M101 is turned on, the automatic circuit starts running. Confirm that the values of D1000 and D2000 will change. Return to Gemini screen. In the Connected Variables window in the lower of screen, values for Gemini are displayed on the left and the values for GX Simulator 3 on the right. You can check that the components move according to the current value received from the simulator. As for the X100 of the sensor, you can check that detection of contact with the frame is output to the simulator. This is the end of the demonstration on how to perform a machine simulation using MELSOFT Gemini.